Morning to all. Today shall discuss about the examples of convergence. First one, test the convergence. Convergence. First one, 1 divided by 3 plus 1 into 2 divided by 3 into 5 plus 1 into 2 into 3 divided by 3 into 5 to 7 plus so on. This is the given series. Next, we find the un. Here un is equal to nth term. Taking the nth term 1, 2, 3 like that, and denominator 3 into 5, 3 into 5 into 7. ಈ ಟರ್ಮ್ ಬರುವಾಗೆ un ಟರ್ಮ್ ಅನ್ನು ತಗೋಬೇಕು. un is equal to 1 into 2 into 3 so on up to n terms divided by here 3, 5, 7 like that to 2n minus 2n plus 1. Taking the 2n plus 1. Okay. Here n is equal to 1. Put the n is equal to 1. Take the n equal to 1. We write the first term. Okay, n is equal to 1. 1 into 2 plus 3. Here 1. Okay, 1 by 3. Next, n equal to 2, 1 by 3 into 2 into 2 into 2 for 5 is the second term like that. And next take the un plus 1, take the n equal to n plus 1 in this function 1, 2, 3 what of n plus 1. Taking the n plus 1th term divided by 3, 5, 7 here 2 n Italy n plus 1 plus 1. Take the n equal to n plus 1. un plus 1 equal to 2, 3 n plus 1 divided by 3, 5, 7, 2n plus 2 plus 1, 2n plus 3. un is equal to 1 n plus 1 divided by 2n plus 3. Next, applying limit n tends to infinity un plus 1 divided by un. This implies limit n tends to infinity un plus 1 is 1 into 2 into 3 n into n plus 1. un plus 1 is n plus 1 terms divided by 3, 5, 7, 2n plus 1. After this term, last term is 2n plus 3. This is the un whole divided by ಅದು ಏನಾಗ್ತದೆ ರೀ ಮಲ್ಟಿಪಲ್ ಇಂಟು reverse this term un term is write like that into 3 into 5 into 7 2n plus 1 divided by 1 into 2 into 3 up to n. Cross multiplication, this is cancels with these terms. These n plus 1 term cancels from this. Okay, remaining terms is limit n tends to infinity. Here n plus 1 in the denominator, this term 2n plus 3. Okay, next applying the limit n tends to infinity. Take the n outside, n into 1 plus 1 divided by n divided by denominator. So take n 2 plus 3 divided by n. Multiplying this term is given. N into 2 2n, 3n, and n cancels 3 4. These terms are cancelled. Applying the limit, this is 1 plus 1 divided by infinity. Here 2 plus 3 divided by infinity is equal to 1 plus 0, 2 plus 0 equal to 1 divided by 2 is L. This is L. L is equal to 1 divided by 2 by Alembrt ratio test. L is equal to 1 by 2 is less than 1. L is less than 1. Given series is therefore given series is convergent. Therefore given series is convergent. First take the un and un plus 1. Next applying the limit. Solving this. After the solving, L is a finite number, less than 1 convergent, greater than 1 divergent. Okay, next problem. Test the convergence. 1 divided by 2 root 1 plus x square divided by 3 root 2 plus x raised to 4 divided by 4 root 3 x raised to 6 divided by 5 root 4. So the infinite series. Here x is a number not given. Next we take the un and vn of the series. Here un is equal to x raised to 2n minus 2 divided by n equal to 2, 3, 4 like that. Here n plus 1 root n. Taking this term, put n equal to 1 comes first term, n equal to 1, 2 into 1 1 minus 1 0, any term raised to 0 equal to 1, n equal to 1 1 plus 1 2 root 1. Okay. Next n equal to 2, 2 into 2 4 minus 2 means x square. Okay. 2 plus 1 3 root 2. Okay, un is correct. Next take the un plus 1. un plus 1. Here take the n equal to n plus 1. X raised to 2 n plus 1 minus 2 divided by n plus 1 plus 1, n equal to n plus 1, already plus 1, root of n equal to n plus 1 is equal to x raised to 2n plus 2, 2n plus 2 minus 2 divided by n plus 1 plus 1, n plus 2 into square root of n plus 1. This implies here 2 cancels, x raised to 2n divided by n plus 2 into square root of n plus 1. This is the un plus 1 term. un plus 1. Next, applying the limit by Alembrt ratio test. Limit n tends to infinity un plus 1 divided by un equal to limit n tends to infinity un plus 1 is this term x raised to 2n divided by n plus 2 square root of n plus 1 divided by un is there, un reverse the terms, un is this n plus 1 square root of n divided by un term x raised to 2n minus 2. Solve this. Limit n tends to infinity x raised to 2n divided by n plus 2 square root of n plus 1 as it is here n plus 1 square root of n not cancels any terms. Here take the x raised to 2n minus 2 is written as x raised to 2n into x raised to minus 2. This is written as the a raised to x to a raised to y, a raised to x plus y. Okay, a raised to x minus a raised to y, a raised to x minus y. Okay, here 2n cancels. Okay, next apply limit n tends to infinity n plus 1 divided by n plus 2 first term plus 1 divided by n plus 2. Next square root of n divided by square root of n plus 1. Take the numerator x square minus this is enough x square. Next limit n tends to infinity outside, n into 1 plus 1 by n. Here also take n 1 plus 2 divided by n. Next term, taking square root of n outside, 1 is remaining term. Here also square root of n being also 1 plus divided by square root of n into x square. And n cancels. Here also cancelling. Limit n tends to infinity. Take the n equal to infinite. 1 plus 1 divided by infinity divided by 1 plus 2 divided by infinity. Okay, n equal to infinite. Here 1 divided by 1 plus 1 divided by square root of n equal to infinite into x square. This is equal to, or this implies 1 plus 0, 1 by infinity 0, 1 plus any number divided by infinity is also 0 into 1 divided by 1 plus 0 into x square. This implies 1 into 1 into x square divided by 1 is equal to x square, is equal to x square. Next, this is not a unique number. X is varying. X is greater than 0 or equal to 0 or less than 0. Okay, but our quantity, remaining quantity is x square. Next, assuming that if x square is less than 1, if summation of un or given series is convergent, x square is greater than 1, summation of un is divergent, x square equal to 1, the ratio test fails. Ratio test fails. Okay, this is the assumption of our series. Next, we take x square equal to 1. Next, we are assuming, but when x square equal to 1, when x square is equal to 1, square is less than 1 convergent, greater than equal to ಆಯ್ತಂದ್ರೆ divergent ರೀ. x square equal to 1, un equal to 1 divided by n plus 1 into square root of n. un, nth term, and taking the Pn, here no terms of n, divided 1 divided by n, highest power of the n is, this is also written as 1 divided by n plus 1 raised n raised to 1 by 2. This is n raised to 1, like that n raised to 1, n raised to 1 by 2 is equal to n raised to 1 plus 1 by 2 is equal to 1 plus 1 by 2 is 2 plus 1 divided by 2. is 3 by 2. N raised to 3 by 2. N raised to 3 divided by 2. Pn is 1 divided by n raised to 3 divided by 2. Next, we using the comparison test 3 condition. Limit n tends to infinity, un divided by pn is equal to, un is this term 1 divided by n plus 1, n raised to 1 by 2 or square root of n, divided by pn is n raised to 3 by 2, taking like that. Limit n tends to infinity, 1 divided by n plus 1 as it is, so root of n, take like that, into root of n into n divided by root n cancels. This is equal to limit n tends to infinity, n divided by n plus 1. Next, take the n outside. Taking n outside, limit n tends to infinity, n into 1 here, n into 1 plus 1 by n, and n cancels, equal to 1. So finite quantity. Applying comparison test 3, L is a finite but and unique quantity. But Pn equal to, here summation of Pn is equal to summation of n raised to summation of 1 divided by n raised to 3 by 2. Here this is the summation of Pn, but therefore P is equal to 3 by 2. Here n raised to P is equal to 3 by 2 is greater than 1. Is greater than 1. By applying the P series, P is greater than 1, summation of un is convergent. Summation of un is convergent, Pn is also convergent. Or Vn is convergent, un is also convergent, vice versa. Summation of un is convergent, then summation of Vn is also convergent. Vice versa, Vn is convergent, un is also convergent, or un is convergent, Vn is also convergent, by applying the P series. Okay. Next example, solve yourself. Discuss the convergence. Discuss the convergence. 1 plus x square divided by root 2 factorial plus x cube divided by 3 factorial plus 1. Solve and send me answer.